Okay, we're alive. So
Sweet.
I haven't seen anything from Michael or heard anything from Michael yet.
Yeah, I haven't either, except for when he was talking about that he might be having people come over to move furniture or something. But
Yeah. Well, I think if you've got your thing at 6, we can get through this pretty quick, real fast, and then do the quiz and be done, type of thing. So.
okay. Sure. Computer's being slow for some reason, but all right, let's go ahead and start.
Okay.
All right. So question 1, what is the sampling distribution? And I got it's the set of all possible values that x could occur. So is that what you got? Similar?
I got set of all possible sample means from a population. So
Okay.
we're right on that same page.
Perfect.
So 2, what is the shape of the sampling distribution of the sample mean when the data are normally distributed? And I got normal, and then in quotes I put like bell shape, just because I need to know what normal is. So
that's what I got as well. So number 3, what is the shape of the distribution of sample means when the data are not normally distributed, but the sample size is large? And I got approximately normal. So is that what you got too?
Yeah, that's what I got as well.
Perfect.
Okay, so 4, how does the shape of the distribution of sample means change when the sample size is increased? And I put, as sample size increases, the shape gets closer to a normal distribution.
Yeah,
and I kind of took that to mean, it may look weird, but as you do more, it looks normal. It gets closer to normal.
Yeah, it'll even out a little bit.
Yeah.
Okay, perfect. What is the difference between the central limit theorem and the law of large numbers? I was intrigued by this question because he said that we should probably understand it. So basically, the central limit theorem is when a sample size is large, the sample mean will be approximately normally distributed. And that's what it means. And then the law of large numbers is as the sample size increases, the standard deviation of the sample mean will get smaller. Standard deviation, yeah, so it gets smaller.
That's what I got too. So
great.
Okay, so when is x normally distributed? It comes from a normally distributed population. Second, if the sample size is sufficiently large.
Yeah, so that's what I got too.
Okay, good. Those 2 questions kind of confuse me a little bit. I'm going to have to do a little more reading on those to make sure I understand 100%, since he kind of hinted we need to know.
Yeah. All right. Part 1 and part A and part B of number 7 is kind of based on your own data, and C for that matter. But I guess for part D, we're supposed to share with each other what we got and then what we noticed about it. So I guess should we just skip to question D?
Yeah.
Okay.
I think we're going to cover some of that in question A anyway. I got the mean is 47,860 for the one side. Okay. I got my random sample.
Mine was 48,500, so just above that, but very close.
Yeah.
And that was a pretty straight on in the graph. So not pretty straight on, but it was a little off, but it was under the 1, so it was pretty normally distributed for both of us.
Yeah, and I think the more we did this, if there was 10 of us doing this, I think we'd see that, because we were shifting a little on the higher side. I think the more people would do it would shift a little, start bringing us back down to about that mean that's showing. So
yeah, that's exactly right. I'm sure that was the intention of the assignment. So that was a good observation.
So
okay,
yeah, that was a pretty good question.
Okay, the Graduate Management Admissions Test, GMAT, is used as an admission criterion in many Masters of Business programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample or n equals 10 students taking the GMAT. And then it says, what is the shape of the distribution of the sample means for such samples? I put normally distributed. Is that what you got?
Yeah, I got that too.
Okay. Perfect. It was kind of a guess on my part, but I guess it was right. So.
Well, and that's, I kind of listened to the lecture a little bit and I had to listen to that part again, but it kind of makes sense as you learn from those other two laws, you know.
Yeah.
So B is, how do you know that the distribution of the sample mean has the shape? And I've got parent population is normal.
Yeah, that's what I got too. Perfect. What is the mean of the sampling distribution of sample mean scores for all such samples? I got 529.
So I got two.
So that was that.
Yeah, that's exactly what I got. So. And then D, what is the standard deviation of the distribution of the sample mean scores for all such samples? I got 35.754.
So I got two. Didn't scroll down my page, but now I see it's 35.574. Perfect.
Cool.
All right. Michael's still not even here yet.
No, I haven't. There's been no emails back from him. So.
Okay. Should we go ahead and do the quiz then?
I think so.
Okay.
Maybe we can get everything done we need to.
All right, I'm going to go ahead and start mine.
Me too.
12 questions. All right. Actually, I guess it's only 10 if you look at it from
Yeah.
the true standpoint.
All right. Okay, so round to 3 decimal places unless otherwise specified, and do not round onto your calculations. It's complete. Okay, so question 3. When you're taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Distribution.
Well, I would think normal.
Just looking at the homework, I don't know what this has to do with it, but for the GMAT question, the shape of the histogram is normally distributed. And then for question B, it says, how do you know that the distribution of the sample mean has the shape? And it says the parent population is normally distributed.
All right.
So maybe it's a direct correlation, and the right skewed parent population will lead to a right skewed.
Yeah, I mean, that makes sense when we look at it.
That's just kind of my logical interpretation. I don't know if it's close or not, but
I like it.
okay. I mean, just based off of that one question in the homework, it seems like if we're going off of that, that
It'll stay the same. Yeah.
Yeah.
Yeah, that works for me.
But the next question is kind of confusing because it says, maybe we should figure this out because the next like 5 questions are this thing. So, all right. Let me look in the book. Because then they get larger, which means that it might be.
It might start going back to that normal.
Yeah, or maybe the amount in the GMAT question was enough to be the same, but maybe the less it is, but.
Well, it would make sense that with a small sample size, you may still stay right skewed. So
that's true.
You know, and then the second question 4 talks about a larger sample size, so it's 100. So I would think, even though it's right skewed, we're going to start to go back into that normal distribution again because you got a bigger sample size. But yeah,
just these websites take a long time to come up, but I'm trying to get to the book textbook and just see what what we got here. Okay. It says if the parent population is normal, then the sampling distribution will always be normally distributed, no matter how many observations are selected. If the parent population is not normal, then the sampling distribution will be approximately normally distributed if the sample size is large enough.
So I think we're right then on the first one.
Well, it says if the parent population is almost normal, mound-shaped, or nearly symmetrical, then the sample size of 5 will probably be sufficient to assure that it was approximately normally distributed. And if it says if the parent population is heavily skewed, then it will require a larger sample size to assure that X will be normally distributed. For most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large to assure X will be approximately normally distributed. So let's see what the question says. The question says it's right skewed, so it'll be skewed right. But then with the larger sample size, that means it'll be more normal, like you were saying.
Right.
And then for the next one,
it does quote 5, right? Didn't it say that?
Yeah, it said 5.
Yeah. And then so for 4, we're going to say normal again, right?
It's when it's normally distributed, then it will be normal. And then if it's 100, it'll be normal as well. I think. Hopefully, we'll find out in a few minutes. But
yeah.
When would the distribution of means be normally distributed?
Which question are you on? Sorry.
Oh, sorry. Number 7. Is that what we're on?
So 5, you said normal as well, right?
Yeah, I put normal for the next 2. So for the sample size of 5 that's normally distributed, I put normal.
Right.
And then for the normally distributed 100, I put also normal. But
Good.
I don't know.
Okay.
That's
yeah. Right. I'm with you there.
Sorry.
Okay, so, sorry, 7. Let's see.
When would the distribution of means be normally distributed? I think this was one of the questions, right?
I think so. Yeah.
It was number 6. When is it normally
Yep.
distributed? And it was when the population is sufficiently large and is drawn from a normal population.
So the second one, data are drawn from population that is normally distributed and the sample size is large. And then
probably then, I don't know if the first one maybe, but
that was what I was looking at too. But it could be the fourth one. I mean, because if it's right skewed, but the sample size is large, would be normal as well, right?
yeah, that's true.
Yeah, 'cause the second, if the sample size is sufficiently large, so I think it's 1, 2, and 4.
1, 2, and 4.
Yeah, because if it's right skewed and samples, I wish he used the number on that third one, but that's my thought. It's 1, 2, and 4.
Well, I'm sure you're right. I'll go with that 1, 2, and 4 with you on that one. Good. Okay. Which of the following gives the best explanation of the central limit theorem? Central limit theorem. The definition was when sample size is large, the sample mean will be approximately normally distributed. Is that one of them on there?
Let's see. If the sample size is large, the sample mean will be close to the population mean. Or if the sample size is large, the sample of distribution sample mean will be approximately normal. Does that sound like it?
Yeah, let me read it again. Let me read that one. When the sample size is large, the sample mean will be approximately normally distributed. So it's like the mean sample will be approximately normally distributed, which sounds like not the fourth one.
Yeah. That's what I was thinking was the fourth one.
Okay.
Okay, so use the following information to answer the next 4 questions. Let x be a random variable with population mean of 10 and population standard deviation of 6. Suppose a sample size of n is 36 is drawn from this population. Okay, so we are...
The mean would be the same, right? 30, or
Yeah, the mean's going to be the 10, right?
yeah, the standard deviation would be 6 too, right? I don't know.
Yeah, it should stay the same. And then regardless of the distribution of the population, if the sample size is large, so what would the shape distribution of the sample mean? It would be normal.
Yeah, so here in the book, yeah, you're right. Here in the book it says a sample size around 30 is traditionally thought to be sufficiently large to assure that x will be approximately normally distributed.
Right.
Perfect. And then it says, what theorem what theorem would justify your response to the last question? I think it's the central limit theorem is what it is, because that's where it falls under on the book. I think it's the central limit theorem.
So the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. This important result is called the central limit theorem. So yeah, I'm with you on that.
Okay.
Central limit theorem.
So I guess we can go ahead and submit it, right?
Yeah, see how it went.
And 92.
Ooh, which one did I miss? Oh, what is the standard deviation of the sample mean, huh? That's what I missed.
Okay. So let's go ahead and redo it. Figure that one out.
And how do we see the score we got previously?
So if you go on My Grades and then Class Progress is where it is.
Oh, okay.
You can see the previous quiz, and then if you go on Quizzes, which is on the left, about halfway down, then you can scroll down to find the group quiz, and then, I don't know, tell me if I'm going too fast, but then you just click the details and then attempt 1, and then you can see what you got right and what you missed. And you can do that on the weekly quizzes or the homework quizzes after they close.
Right.
So that's how you get there.
So we're on lesson, which one? Lesson 5. Oh, cool. Okay.
Did you find it?
Yep. Sorry.
No, that's okay. I'm not looking at you, so
Yeah,
okay.
neither.
Couldn't know if you were working or if you weren't working.
Okay.
10.
Oh, I pulled up the last week's test. That's great. All right. So question 3, we got normal, right?
Yeah. Let me read it to you. So it's skewed right, and then for 4 it's normal. 5 was normal.
Skewed right, normal for 4.
Number 5 was also normal.
Normal. Okay.
Number 6 was normal. Number 7 was 1, 2, and 4. Number 8 was the fourth one.
Okay.
Number 9 was 10. Number 10 we missed, so we'll have to do
So
that
we'll
one.
look at that one. Okay.
Number 11 was normal. And number 12 was the central limit theorem.
Okay. All right. So let's look at number 10. What is the standard deviation of the distribution of sample means? So it should be the standard deviation according to the book of the sample mean should be O divided by n, the square root of n. Let's see if that
So
makes
that's
sense.
so it'll be 1, right? Because 6 divided by the square root of 36. 36 is square root of 36 is 6, so it's 6 divided by 6, which is 1.
Is 1, yeah?
Correct me if I'm wrong.
No, I mean, I can run through my calculator real quick to double check you, but so the 36, the square root is 6, and 6 divided by 6 is 1. So yeah.
Well, hopefully I'm right. Sorry if I'm not.
No.
Yep, looks like you got it.
Yep, sure does. It's 100%.
Great. Well, thanks for meeting with me and helping me out and stuff. Really
Yeah, no
appreciate
problem. No problem
it.
at
I
all.
guess we'll
Thanks
see
for
you on Thursday.
attending. Yeah.
At normal time, I assume, right?
Yep. Unless you need it early, and then, like I said, I can be flexible, so that's not a big deal.
All right. I'll let you know. Sorry about today. It was kind of like we can do it, but we can't. So
Yeah, that's not a concern there. So I
All
will
right.
post the meeting in the place where we post it, and we'll.
Oh yeah, just so you know, the reason I always comment on your post is because on my end, I like to see everything complete for the week, and if I don't go in there and post on it, then so I'm just always like, thank you, Eric, for posting.
Yeah, that's not a problem at all. I'm glad you're double checking because I'm always half afraid that I'm either going to forget to start the broadcast or I'll forget to post it, and we'll be out of point. So I appreciate
Yeah,
that.
well, yeah, thanks. Oh, it looks like Michael just joined in.
Yeah.
Hey guys, sorry I'm late. And by late, I mean way late.
No worries. We've been there.
It's ridiculous. I just thought, like, every time they would give me a new ETA, I was like, all right, this is the time. It'll work this time. Hey, sorry, we're running late again. All right.
Yeah, that's no fun.
Yep, such is life. That's all right. Okay. Have you guys already gone through the quiz? Are you already done?
Yeah, we just finished the quiz.
Oh, gotcha. I can take it on my own, in all honesty. Are there any concepts and things that you guys wanted to go over while we were together?
I don't think so. Just watch the quiz and make sure you're looking at your notes because I mean it was a pretty easy quiz, but there was one that was kind of tricky. So just watch that.
Now, I was under the impression as well that that we could still use like our notes, our Excel calculators, and things that we built and stuff like that while reading the text for these quizzes. That's the impression that I was given. Is that good?
I think, and I'd have to reopen the quiz, but I think it says you can use your notes on the quiz. But I think it says it right as you click it to open it up. So I think you're okay. Just read that note. It should clarify.
Cool. Excellent. Well, I'll do that. Guys, I am so sorry that I didn't make it for the majority of the meeting. Like, the last couple seconds doesn't really save me.
Oh, that's all good. We've all been there.
Yep. Yeah. So is 5:30 gonna or 5 o'clock gonna work next Thursday for you? Jeepers, I'm already a week off.
Yeah, Thursday 5:30 or 5 on
5,
Thursday
yeah.
should work fine. Either way, I'm going to have to cut out time for class meetings. Unfortunately, I work overnight is the deal, so I usually try and not wake up as many times as possible during the day, but unfortunately, it seems like all my professors have conspired to have a group, some group meeting of some type that they've thrown me into in every class,
Right.
and they all meet during the day. So whatever, I'll cut out time. I'll make it work.
Okay. Cool. All right, then I'll see you both of you on Thursday, 5 o'clock.
All right, later.
Yep, later.